I haven't done many of these extra kind of extension pages, but this one was a really, really meaty one. Lots of work in it. I think it was really good. It's the chapter 10 kind of extension. So you've got these 3 different sized tins of soup and then a cuboid carton as well. This side is pretty straightforward. Calculate the volume of each one and then the capacity in litres. So there's 1,000 cubic centimetres in a litre. 1 cubic centimetre is a milliliter, if you didn't know that already. So there's obviously 1,000 of those because it's millimetre. Think back to the previous chapter when we were looking at standard form and such like. Then the surface area of each container, straightforward. Then for each container, calculate the volume of soup divided by 1 pence. That's fairly simple, divided by the price. And then we're looking at how the volume of the box. So there's 12 on a layer, 2 layers per box. How much soup is in the box? What's the volume of the soup in the box, and what's the volume of the box? And then divide the volume of soup by the box to get the percentage. So it says calculate the total volume of the soup in the box as a percentage of the volume of the box. That's pretty straightforward. So that's the volume of all the soup divided by the volume of the box times 100. But the bit that caused a bit of a problem was this. What if we were to put the tins in the box like this? It's still 12 per layer. There's still 2 layers. Would that be more efficient? My first guess would be no, because that's not what supermarkets do, and they would do it if it was better. But we need to do the maths, don't we? And working out some of the geometry here was tricky. So let's draw this 1, 2, 3, 4. Obviously your tins don't overlap. This is just me drawing badly. 1, 2, 3, 4, and then 1, 2, 3, 4. That's drawn pretty badly, but I think you get it. Okay, so please do this before you watch the rest of this video. What are the dimensions of the box? Well, the height is pretty straightforward. The height is still 2 tins, so double the tin. And I think it asks you to do this for each tin. Anyway, so whichever tin you're looking at, it's either 10, 11 or 12 centimeters doubled because there's 2 layers. So, but it's this geometry here. So what is, let's call this X. What is X and what is Y? I'm going to go for the large tin because it's 8 centimeters in diameter. Makes the maths easy. Okay, so this is obviously 1, 2, 3, 4 tins along. So that's 4 times 8. So up until, let's look at this bottom bit here. So that's 8, that's 8, that's 8, that's 8. So that's 32. But then how much is this little gap? Now if you look carefully, so here's the center here. That center lines up with the edge of this one. Therefore, this edge here is going to line up with the center of that tin, isn't it? So this extra bit, I mean, it's actually easier to look at this drawing. Do I have it? Okay, here we go. Yeah, so the edge of this tin lines up with the center there. So we've just got half a tin sticking over. So we've got 8, 8, 8, 8 plus 4. So that's 32 plus 4, that's 36. So the X is 36 centimeters. But what about this? What about this one? Well, there's a clue here. There's a clue here. Let's look at that triangle. So let's draw that. What we're doing here, let me get a different color. is we're looking at that triangle. So that will be the edge of this. That one is that one there, that one is that one there. And the edge of this circle lines up with the center here, the edge of this one lines up with the center there. So what are these dimensions? Let's just draw this blue triangle in there. Ooh, wow, first of all, we know it's a right-angled triangle. I sense a bit of Pythagoras coming on. This is what we want to know. What we do know is this. That's a radius. In this case, it's 4. And this here, we know this because look, here to here is a radius. Here to here is a radius. Well, that's 8, isn't it then? So let's draw this triangle separately. 4, 8, and then whatever this is. Let's call that y. Remember, if I still, yeah, you can still see. So, but I don't need to do it. I don't need to do it. This squared minus this squared will give you that squared. Great. Off you go.